Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is 5 types of drilling. Let's see here. The goal of today's webinar is to learn about the 5 types of drilling features and how to use them. As you know, my name is Depoalo. I'm the voice of the BobCAD After Dark video series. You can find me on Instagram at BobCAD-CAM. You can also search hashtag BobCAD or hashtag BobCAM. All right, what am I going to learn today? Well, today we're talking about drilling, and believe it or not, there are a lot of different ways that you can drill holes, whether it's 2-axis features, 3-axis drilling features, cross-drilling, or multi-axis. BobCAD's got you covered, and those are what we're going to learn about here today. With BobCAD, you can always expect fewer steps, better cuts, and more profit. So while I get my screen set up here, let's go ahead and get a shout out just where you're from, where you're located. That'd be great. I know some of you got started in the early mix, so I appreciate everybody showing up. We got Richard from Cary, Illinois. We got Larry from Savannah, Illinois. Reginald is out of San Diego. Jason is out of Mentor, Ohio. John's in Palm Harbor. I really want to meet up with you, John. You're right up the road from us here. Thomas out of Massachusetts. We got Bob out of Orange County, New York, probably up on, or no, that's Ken. Is that Bob? Bob, you're up in Orange County Choppers, Route 6, Middletown. Yeah, I know a little bit about that area. We got Ken in New Hampshire. Michael out of England, thank you so much for showing up to here. I want to take a moment to really thank you for spending some time with me here today. I know you guys are busy, and I really enjoy spending time with you talking about all the different features that we have in BobCAD. So I really appreciate you spending some time here. Now, a little bit of housekeeping. It's important that whatever questions you guys have about today's topic, go ahead and fire them away. That is the point of these webinars, is to answer your questions. Today's topic is drilling in 5 different features. The other thing that is important for me as well is what version of the software you're running. If you're running BobCAD version 30 or earlier versions, whatever version is, if you can write in the question and answer section, which is how you communicate with me, just go ahead and write in what version you have. Now, if this is your first webinar, go ahead and say, this is my first webinar. And if you are not running BobCAD, unfortunately, if you are unfortunately not running BobCAD, just go ahead and say, I am not running BobCAD. And if you want, you can say what software you use or how you program your machines. Other than that, we're ready to get started. Now, the first question that I have for you is, when drilling holes, what kind of geometry can you select? When drilling holes, what kind of geometry can you select? And that's our first file here. Now, if you know this answer, and you should know this answer, but it's important that you know there are different geometry types that you can work with when setting up your drill features. Okay, in this example here, I have a couple of different types of geometry. The first group here is, these are just points. Okay, so I have point locations. Now, Larry said points, arcs, and holes. Ray says arcs, points, and faces. That is correct. We can work with points. We can work with arcs. Okay, and then we can also work with these surfaces here. Those are the 3 types of geometry that you can support or that you can select when drilling. It's also important to understand that when drilling, you can select a complete circle or even partial circles. This is a 180, this is a 180. That's like a 45-degree segment of a circle. Okay, so it's important to understand that. Let me get into the tree here. Let's just get something set up. Let's see. Bounding box. It's picking up my model here. Why is it just picking up that section? Really doesn't matter for today's example, so we'll get back to that in a minute. All right, so we have points, we have arcs, arc segments, and we have surfaces. Now, here's the thing with these points here. I just want to touch on this real quick. This is a little sidebar. You can adjust your point styles. I don't know if you guys know this or not. If you look under preferences, setting default, but I'm going to look at settings part here. You have point styles, and there's a couple of different types of points that you guys can use. I usually just use the dot style. Okay. You can change your point styles. There's some of these other methods of describing point locations come in handy. It may be how you what you were used to with the AutoCAD program you learned 20 years ago, or whatever the case is. So I just want you to know that there are different point styles that you guys can utilize. You can make your point sizes bigger or smaller. That is under preferences. You can change it for the part that you're working on, or you could change it as a default. So just a little fun fact for you there. Okay, so we want to talk about drilling. I get a lot of questions. What question? If you guys have a question about drilling with points, lines, or arcs, go ahead and fire it away. I do get a lot of questions about drilling. There's a very specific topic that comes up a lot, and I'm going to address that here today. That has to do with saving a drill feature and not having it reset the depth value. This does come up quite a bit. But let's go ahead and get a drill cycle going here. We're going to choose select geometry. Now, one of the things that you're going to notice over here, guys, is when you're picking your geometry or selecting your geometry, there are some different types of drilling cycles here. All right, so depending on what you're doing, you have a standard drill cycle, you have a multi-axis drill cycle, and you have a cross drill cycle. Okay, to start with, we're going to start with the standard drill cycle. Okay. You're going to notice that there's also this point and arc usage. Ignore Z, use as top, use as bottom. All right. So what do I mean? How can you use some of these features? Well, for now, we're going to just have a standard drill cycle, ignore Z. What we're going to do is we're going to select these point locations. Okay. Now, there is some logic that's built into the BobCAD software for holes. Okay. So I'm going to select these point locations. I'm going to choose OK. One of the things that you're going to notice right away when it comes to the hole size here, the values are set to a 1/2 inch and a 1/2 inch. All right. The reason why this is happening is because there is no other information that's going on there. Okay. We just selected a point location. Now, you can adjust the diameter here. You could change the size. You could change the depth here. You could pick a depth or pick a bottom off the model. You'll see in our table here, it will adjust. Why is there a table here? This table specifically, if you look at this here, this table, what this would do is if you had picked radiuses, it would list out the different size radiuses. So, and the reason why that is because you can actually drill multiple hole sizes at the same time, okay? Something that can speed up your programming depending on your experience. A lot of times I just deal with the holes separately because I feel I'm pretty confident with my layers. Okay, so we selected our geometry. Again, we picked these point locations. We chose OK. All right, when I reselected, and this is actually a great point, I reselected here. If you look at my diameter, it reset to a 1/2 inch. Let's go to a 1/4 inch again. Okay, we changed it to a 1/4 inch. If I reselect these point locations, just by reselecting it, you can see the hole diameter resets to a 1/2 inch. Why does that happen? It's because of the logic that's built into the drilling cycle. So don't get frustrated about that. No, if you reselect point locations, okay, it's going to reset it to a 1/2 inch. It's just important that you understand that, okay? So we have our point locations. From here, what we can do is we can go to our machining strategy and we could build in a different cycle. So we center or spot, and then we're going to drill. Those are going to be the two. I'm just going to compute the defaults here, and we can see that we drilled these holes, okay? All right, so you can select points. Now, the other thing you can do, let's remove this selection and reselect. And what I'm going to do is I'm going to pick these radiuses here, all right? So you can select points, but you can also select partial arcs, okay? So when we do that, let's get back to our machining feature. You're going to see that there is a value here. Actually, let me do it from the beginning. So the first one, let me clear this one out. We'll delete this guy. We're going to do drill hole, select geometry, 1, 2, 3, 4, 5, 6, 7. We get all these selected. Okay, it will read the diameter now. It's going to read the diameter because when we select geometry, it reads the diameter. Okay. If we choose next here, we can go to our machining strategy. We could pick up our center drill and our drill. We can compute, and then now we're programming those. Okay. So whether if I'm going to do another one here, I'm just going to do drill hole, select geometry. Okay, I'm going to window pick in these point locations. I'm going to set what my diameter is. I'll go to my machining strategy. I'm going to do a center drill and a drill, and I'll compute. So this first group, we program based off the points. This second group here, let's reverse these. Okay, this second group here, we program based off of arcs and partial arcs. This third group, let's go ahead and do it. We'll go mill, let's do this, mill drill hole. Select geometry. This one, I'm going to select these cylindrical faces. A lot of times when I'm in this selection method, what I'll do, guys, is I'll hit T for transparent, and then this way, when my mouse highlights over the hole, it previews. It's just a little trick that I do that makes it a little easier to see what's going on. We'll go ahead and select all these. It will read the whole diameter. Pick bottom. Let's see here. Pick the bottom, and it's actually reading the whole size or the whole depth as well. Okay, so we'll go over here to our strategy. We'll say hole, and we'll compute. So we have 3 different sets of geometry. We have points. You can select your points and drill. You have arcs and arc segments. Okay, and we have our cylindrical faces. Now, when you're dealing with the wireframe group here, because you've just selected point geometry, it will reset if I reselect this, so if I go into this feature, okay, and let's see, I got to do it from this screen. If I reselect this feature here and I choose OK, what that will do is change my hole size. Now, it's not doing it right. Of course, it's not doing it right in this workflow here, but because you're working off that point, if you reselect your geometry, you can lose some of your information. Some of the information could be the depth. The other information could be the diameter size, because there is logic that occurs. And if you're just giving it a point, you're not giving it a lot to work off of. Okay. If we go to the next group here, you can select portions of the arc or the complete arc. Okay. If you reselect here and choose OK, it won't change your diameter, your hole size, because it's read your hole size in, but it could change your depth. I'm going to just make this to 750. We'll compute it. So I just made the depth a little bit deeper. If I come in here and I reselect, okay, and I just recompute, we should see, or I'm expecting the depth to change, but the depth did stay the same here. But this can happen when you reselect geometry. The depth could change. All right. And then the last one here is when you're selecting cylinders, okay, it will not only read the whole diameter, but it's also going to pick up the whole depth based off the cylinder. So 3 different types of geometry, 3 things to expect. Points, it's not going to read any hole size because it's not going to know. It's just picking up the X, Y, and defaulting to the depth location. Arcs, it will read your arc sizes and call the drill size based off of that. But the depths, it's going to default to a 1/2 inch because it doesn't have anything else to work off of. And then with your surfaces, if you select your surfaces, it will read the whole diameter, but it will also read the whole depth. So those are 3 different settings that are going on there. George has a question, setting for drill tip allowance. There is a setting for drill tip allowance. If we go into any one of these, let's go to the drill cycle, and then we'll go to its parameters. You're going to see an effective depth. Okay, you're going to see an effective depth over here. This is the effective depth, and then you have the overall depth. So the effective depth is lesser the tip angle. The overall depth, that value is the one, this value right here. The overall depth, that is the value that would be posted in your G-code programs. Okay, so if you have your tool set up with a proper tip angle, it will calculate the effective depth for you, and then it will post the overall depth so that it's doing the drill tip comp for you. Okay, so that's how that works. Does that make sense, George? I'm pretty sure that it does. So we're going to just keep going here. All right. So here's the thing. What's the next thing that I want to do here? Now, it's very common. So we talked about point locations, arcs, arc segments, and surfaces. It is very common that you may want to reuse a lot of these drill cycles. You're welcome, George. This drill cycle is actually very basic. I'm not even too concerned about the series of tools that I'm using or what their settings are. But the one thing that I want to talk about is reusing drill features here. So I'm going to edit this feature. I have my center drill in my drill. That's fine. Okay, I'm going to go to my feature page here. And this depth I'm going to set to 1 1/4. All right, I'm going to recompute that cycle. So now I have this drill cycle. I have a center drill, a spot drill, and a drill. It's a 1/4 inch, and it goes to 1 1/4 inch depth. Now I may be in another setup. I may be in another job. What I want to do is I may be in an index system. I want to take this feature and I want to copy it, and then I want to paste it. Okay, so I'm going to copy and paste that feature. And then what I want to do is reselect geometry. So I'm going to pick these holes again, okay? So there's a couple of things that can happen when you do this. So I'm going to pick these holes, I'm going to compute, and then I'm going to compute. All right, so one of the things that you're going to notice that happened right away, if I go to a front view, is this was at 1 1/4 depth. This one defaulted back to a 1/2 inch depth. I took this feature, okay, I copied it, I pasted it. I wanted to use all the same settings, but then my depth was not the same. Okay, let's take this same feature again. We're going to copy that feature, and then we're going to paste that feature. We're going to reselect our geometry, and what we're going to do is pick these cylindrical faces here. Okay. All right, so we got those going. We're going to go ahead and compute this one, and we're going to go ahead and compute that one. If we look at our geometry here again, we're going to see that this was defaulted to this 1/2 inch depth. So it's really common that people want to reuse these drilling cycles and use them in other locations. And really, that is the next topic here, which is how can I optimize my drilling cycles? You know, how can I optimize my drilling cycles? Whether that's reusing cycles that you've used already, whether that's shortening the cycle time. So the first thing I'm talking about is how to reuse these drill cycles. They could be drill cycles, tap cycles, counterbore cycles. They could be all kinds of things. But how are we going to retain the settings that we have in this feature, because we're going to save it and use it in another job? And it's really easy. What we're going to do is edit this feature. Okay. We're going to go to our drill parameters, and you're going to see this, this option right here. This option, use cutting conditions, okay? And then you'll also see how the effective depth and the overall depth are grayed out, right? So what we're going to do instead is we're going to uncheck use cutting conditions. That is the trick here. How you are able to retain these values is this section right here. You want to uncheck use cutting conditions, okay? When you do that, what's going to happen is, well, let's see. So we're going to finish this cycle here, or yeah, we can even compute it. We'll compute the cycle. Okay, so now we're going to do the same thing. We're going to take this feature, we're going to copy, we're going to then paste that feature, we're going to reselect our geometry, and we're going to pick these groups of holes here. All right, so we get those set. We're going to compute the first one, we'll compute the second one, and you'll see how now the depth that we used has carried over with that feature. So that is a big option in the software. Probably the #1 question that I get about drilling cycles has to do with retaining those values, and you guys are now all in the know. If there's any questions about that, go ahead and fire away. A couple of the other things that I want to talk about when we're dealing with drilling optimization, if we edit our feature here and we look under our, let's see here, machine sequence. Okay, under the machine sequence section, one of the other optimizers that we have is this one right here. This one's called reverse each operation. It should be defaulted on. If you're cutting a larger part and you're going from one end to the other end, you can reverse the option. So it drills from left to right. changes the tool, drills from right to left, like when you spot to the drill cycle. So that's another big option for you here. Another thing that we have as well as far as optimizing, let me erase all here. Let me go back to a pen. Another option that we have for optimizing is being able to program multiple hole sizes at the same time. Okay, so you can do a drill hole, select geometry, and literally window in or select multiple holes at the same time. This table here shows each of the different hole sizes. This allows you to program multiple holes at the same time, so you don't have to select them separately. You'll notice when you get through the wizard, it will have a feature set up for each hole size, and then that way you can program it. That is another optimizing method. Generally, I find myself sorting the geometry and working with one hole size at a time, but some users find that very, very useful, and it all depends on the kind of work that you do. So, all right, another method of optimizing is being able to program multiple hole sizes at the same time, okay? Another method of optimizing would be using the same spot drill to drill different hole sizes. So, for this one here, I'm just going to change this from the number 5, which is the default, to, one of these 3/8 spot drill. Okay, so I'm going to say that one's going to be a 3/8. This one is going to be the 3/8 spot drill, and this one's going to be the 3/8 spot drill. So I'm using the same spot drill on all the holes. Okay. For this one, I'm just going to load over a drill cycle. Let's see, machining strategy. I'll load over a drill cycle, and then we'll do the same over here. The reason why I'm doing this is just to get a couple of tools up on the screen. We'll go ahead and compute this. So here you can see I programmed all these holes pretty quickly. And when we look at our machining order, you can see that all the center drills run first. Okay, so this is another method of optimization. We can use that same center drill on multiple holes, and then we can spot all the holes in one routine versus spotting, drilling. Okay, so that's another optimizer for you. The last one that I have for optimization of these drill cycles here just would be some of the sorting control. When you get into machine sequence, you have a closest order, a pick order, an X direction, a Y direction, a custom direction, or an optimized direction. Again, this is a way in which you can optimize your drilling cycles. Okay, so the takeaway on that is, one, when you want to retain the depth value of a drill feature, you'll go to the drill parameters page and you'll uncheck use cutting conditions. Okay. That's number 1. Number 2, for optimizing your drill cycles, you can go to your machine sequence and use the reverse each operation, so that way it cuts in a reverse order. Okay. Number 3, when dealing with parts that have multiple hole geometry sets or multiple hole sizes that you want to drill, you can select them all at one shot and be able to program it. And you can see doing so gave us our 3 different features here. Okay. And then another one is using the same spot drill for different hole sizes. And then, like you can see with the machining order, we're going to go through and be able to spot all the holes with the same tool. Okay, so if there's any questions about that, let's go ahead and talk about it. Otherwise, we're going to move on to the next topic. The next question is, can you program holes that start at different Z direction or different Z points or at different Z heights? Okay. If we look at our part model here, you can see that we have some counter bores and we have some holes that are down in the bottom of that counter bore. Can you program them at the same time? Now, one of the things that I want you to look at here in each one of these features, using spot drill to leave a chamfer method, I would agree with you, Thomas. A lot of times instead of spotting, drilling, and then chamfering, you could chamfer with your spot drill. That is another good optimizer. So good call, Thomas. What we're talking about now is really these hole groups. How do you program at different Z levels? If you look at this section of the drill wizard here, it's the hole groups. It will have the group, it will have where it starts, and it has how deep it's going to go. You can use these hole groups to be able to program holes that start at different Z depths. Okay, so that is the next topic here. All right, erase all this. Let's get out of this guy. Let me go to, let's see what number 3 has. Okay, so here is an example where we're drilling some holes. We want to drill on the top, and then we want to drill on the bottom. Okay, this is done with a single feature. It is possible that we could have done this with 2 different features. What you might do, let's go ahead and edit this. We'll go to our parameters. We'll uncheck that. We'll recompute. We're going to reselect. Okay, so what might be happening here, we can select these 2, compute. Okay, we can take this feature, copy, paste, select geometry. We can go this one and this one. Okay, so that's one method of where you're using multiple features in order to drill holes that are starting at different Z-planes. Now, the thing with that is, you have more features in the tree, more to keep track of. Okay, so instead of using multiple features, what you can use is the hole groups. So I'm going to select these holes again, this one and this one and this one and this one. Okay, I'm going to edit my feature here. So we'll see top of feature, feature depth. Okay, so top of feature for the first group, I'm going to do pick top. Top of feature is going to be here. Top of feature for the second group, I'm going to do pick top. Top of feature is going to be here. I'll go ahead and compute this, and you can see how we can program these holes at different Z heights. Okay, so that is, can you program holes at different Z points or Z heights? The answer is yes. The way that you do that is with your hole groups. That's one of the reasons why you're going to use your hole groups. The other thing you'll notice that I did copy this feature, and by unchecking using the cutting conditions on the parameters page, I'm able to retain the depth settings that I'm using there. Okay, so again, good information for you. Hole groups is the takeaway when you're drilling points at, or drilling holes at different Z depths. Now let's take a look at another file here. This is another example where we have some holes that are on the top, and 3 different levels of holes. Again, let's run this through a stock wizard real quick. Okay, so we'll blank this out. We're going to do drill hole, select geometry. I'm going to pick this face here. That is fine. We're going to do, this is a blind hole. Next, all right, top of feature, pick top. I'm going to pick the top here. I have my depth. We'll go to our machining strategy. We'll compute. Okay, so we have, this is going to come down and spot the hole. This is going to come down and drill the hole. Okay, so what we want to do is we want to drill at all these different levels. Let's see, John, how would you use the center drill to do a chamfer? John, that's a really good question. It's really pretty easy to set up. What we'll do is, instead of using a center drill, I'm going to use a spot drill. I think that's probably a little more common. So I'll use a 3/8 spot here, and I'll say OK and finish. What I want to do is I want to measure what this diameter is here. So I'll just measure this. This is a 1/604 radius. So we'll get back into the cam tree here. We're going to go to our center or spot drill. We'll go to its parameters. So what you're going to see here is a depth. So it's an 80th thou depth. That's the default, John. If we want to add that chamfer there with the spot, what we're going to do is just define the center diameter. So this is going to be 0.1604 times 2, because this is the radius that I'm reading here. Okay, and then with that value, I'm just going to hit tab. It will calculate the depth in order to chamfer that hole. So using that spot drill, I'm able to chamfer that hole. I'm going to go ahead and compute this. We'll bring our spot drill in here. We can step forward, and you can see how it's going to come in there, and it's going to put that chamfer right on the part. So when I spot, I'm chamfering. Hopefully that makes sense to you. Okay, very good. So we have this feature set up here. I'm going to edit this feature. I mean, this is kind of a weird, a different workflow. I generally would select all the holes at one time. What I want to do is just go to my parameters, uncheck use cutting conditions. So I'm defaulting what the depth is. I'm going to finish. I'm going to reselect my geometry. I'm going to pick all the cylindrical faces that I want to work with. Again, you could do this with 3 different drill features, or you could do it just with one. We're going to say OK here. All right. I'm going to come into our setting here, and you can see I have a couple of different groups. Now, one of the things that you guys see me skip all the time, clear answer to my question, thank you. You're welcome. Use spot drill to leave chamfer methods. Okay. Okay. I guess that was your question too, Tom, instead of John's question there. But very good. Okay. So we got one of the steps that I skip often is when I'm running through the stock wizard, I skip setting up the workpiece. And if you look in this window here, we're not able to see the workpiece or the part model that we're working on in this simulation window. This window or visualization window, this will help you with your whole groups to show you where things are. Okay, so what I'm going to do is finish here. I'm going to run through the stock wizard again. Let's see. I'm sorry, workpiece selection. I'm going to select the part model here. Let me blank out the stock. So I added the part model as my workpiece. I'm going to go ahead and edit this again, and now you'll actually see the part model in the simulation. This way, as you go through these different features, okay, you can see exactly where they're at on the part. That is the purpose of this simulation window. Now, with these whole groups, I'm actually going to take group number 2, and I'm going to break the whole group. What that's going to do is give me, let me break this group too. So I have 1, 2, 3, 4. These are all the holes that are on the top of the part. So I'm going to regroup that. So regroup those holes. Now that makes that one group. Okay. Or what I expected to be one group. This one should be a 0. It may be because it had that depth there. Let me break it again. So we have this one, this one, this one, and this one. Let's regroup to put them all together. Okay, so now we have one group for the top. This next one here, what I'm actually going to do is pick top, and then I'll come in and I want to pick the top face there, so that's where it's going to start cutting from, so that one's good. The next one here, this one's on the bottom, so I'm going to do pick top, and then we'll just grab the top of that chamfer there, and then we'll compute, and you can see how we're able to program all these different holes at different Z heights. Okay, so that, the question is, can you program holes that start at different Z heights or Z points? The answer is yes. Some of you may be wondering, what are these clearance planes here? So you can see there's hole-to-hole moves, and then there's also between hole groups at a different clearance height. If you get into the feature here, there's your group retracts, and this is where that value is coming from. There are a couple of types. There's plane, cylinder or sphere. In this case, plane is just fine. We could drop this size down maybe and recompute it. You can see they're not going up as high there. All right, if there's any questions about that file, go ahead and let me know. Whole groups is the method in which you can program drill features that start at different heights. Okay, let's look at the next file here, which is this one. This might be, you might consider this for maybe water lines that you have in tooling. This is what I would consider 3D or 3-axis drilling, when you have holes that are along a curved surface that go to different depths. In this example here, let me pick the solid model as our stock. Let's go ahead. The 0 position, again, I'm not too concerned with. All right, we'll blank out this. We're going to load our drill hole feature, select geometry, and I'm going to come through and select these faces here. Now, again, I'm going to hit transparent, and by hitting transparent, once that hole highlights, I'm able to window pick it. Now, this part here, some of you may be saying, well, why can't you do a window selection? All right, so let's grab all of these here. Actually, let me delete it all. I'll do a window selection. And doing the window selection, it's just going to pick up all these different faces. So that's not really the best method for this. You do want to pick the cylindrical faces that you want to work with. Now, if you had a bunch of them that you were dealing with, you might be able to, there are other ways to kind of come at this a little quicker. You could do like a group selection as such, and then unselect maybe the stuff that you didn't want. That would be quicker than picking them one at a time. So you do have some options there. You just don't have an option to just pick the whole model and have it find all the holes for a standard drill cycle. Eric has a question. I want to know something about side roughing. Okay, Eric, at the end of the webinar, we can talk about side roughing. Okay, so we have all our holes selected. We have multiple depths. These are going to be blind holes. All right, you can see the starting and stopping location of each of the different groups of holes here. Again, we can go to our machining strategy, set it, our drill, our spot, and then our drill cycle. We can compute, and then here we can see we have all of our holes being programmed for the different depths. Now, our retracts are pretty high here. Again, we can make an adjustment to that. We can go to our group retract. We could make this smaller and recompute, and then that will drop them down, drop that height down. We probably make it even smaller than that. Let's make it, I don't know, let's say 0. What does that give us? Comes down a little bit here. There are some tricks that we could use in order to drop down these rapids. We may not want all of these rapids to go where they're at. Let's blank this one out here. Let's look at just this one drill cycle. We can choose edit. What we're going to do is move. We're going to drag, and well, first we need to select what we want to move. So I'm going to select all these rapid positions here, all those rapid positions, and then we want to do a drag, and then we're going to just drag these down closer to that surface. So this way we can cut out that air time. We'll execute and OK. And this is, again, one of the methods that you can use the toolpath editor to edit your toolpath. So just, again, a quick sample of 3-axis drilling. If there's any questions about that, go ahead and fire away. The other topic that I have here, can you save a drill feature to use on other projects? Now, whether you use the copy and paste method that we showed earlier, let's blank on blank. Let's go, let's see here. Let's say you want to use this feature here, okay? If you're going to reuse that machining strategy or that drill cycle, that tap cycle, Bob, you need version 30 for the toolpath editor that I just showed you. The whole groups are in version 28, so you can do the, I believe they're in 28, so you can do the 3-axis drilling in version 28, but the toolpath editor you need version 34. Okay, so if you're going to save this feature or you're going to copy and paste it and use it in a different on a different project, what you're going to want to do again is under parameters here, you're going to want to uncheck use cutting conditions. Again, I just want to make sure everybody's on the same page here. Uncheck use cutting conditions here. What that does is it will retain the depth value of your holes. Okay, so it's important. That's how you utilize that. Again, you can use the copy and paste. So we can go down here, copy, and then paste. Generally, we'll use copy and paste within the same part file. So if you're in a setup, in an index system, in a job, you might even have separate jobs that you're copying and pasting from. Generally, that's where we'll use copy and paste. If we're going to go from one file to another file, instead of using copy and paste, what we'll do is we'll take this feature and we'll save this feature. It'll save it to a directory. And then from there, you can load up, you can come in here and load a feature. So you could do save, and then you could, save a feature, and then you could also do load a feature. So that's another method that you can use in order to take a drill feature, whether it's a tap cycle, a drilling cycle, a counterbore cycle, and be able to use it on other projects. Question came in from Danielle. You drill a 18 millimeter hole chamfer it with a 25 millimeter chamfer. Small diameter equals 0, feed plane is 1. The result is where we are cutting air for about 9 millimeters before the chamfer drill touches material. Daniel, I'm not sure exactly why you're running into that issue if that's what you're experiencing. What you have here is you have the rapid plane and you have the feed plane. It's gonna come down to your feed plane and then it's gonna feed from there. For your hole-to-hole movements, I'm curious of whether you're running G99 or G98 and also what control you have because it may just be in the post processor itself. So we can pick that up after today's webinar and spend a little more time on that. All right. Okay. So again, the takeaway for can you save a drill feature to use on future projects? Again, the key to this right here, and I can't stress it enough, is to uncheck use cutting conditions. And then, that way you can copy and paste and you can save and load. All right. Now, who's got a fourth axis? If you got a fourth axis, go ahead and say, I have a fourth axis. Let me see. Vic's got one. All right. Very good. Let's see. Bill's got one. Ray's got one. I mean, I don't know. Yes, I have. You should have a fourth axis. If you're running a 3-axis machine, you should definitely have a fourth axis. There's a lot of stuff that you guys can do on there. Let's see here. This is the file that I want to look at right now. This is kind of set up more for like a mill turn type job, but it's definitely a concept that I want to go through with you guys. So far, what we've shown. Let's just go solid model here. So far, what we've shown is just standard drill cycles. Let's go to a top view. I really want my origin to be over here, and I want my x-axis to swap. Okay. I got this over here. That's fine. And let's blank this out. Okay, so with your 4-axis, a lot of times Integrity Machining has one. I'm sure you do, Bill. I'm positive you have a 4th axis. So here's the thing. A lot of times you may have to drill on parts along the OD of your part. So far, everything we've shown you has been the standard drill cycle. If we go mill, drill, hole, and we select geometry, you can see we've been doing the standard drill cycle. Now, I didn't talk about point arc usage, but in your wireframe, you can use either your point or your arc either as the starting point or how deep you want to go, or you could ignore it altogether. Okay, so that has to do with the point and arc usage for standard drilling. Standard drilling, we can drill points, we can drill arcs, we can drill off of surfaces. If you need to drill holes at different depths, you use the hole groups in order to accommodate that. When you get over to your 4th axis, or your mill turn machine, this is where you're going to start utilizing cross drilling. Okay, and cross drilling is probably one of my favorite drill cycles for BobCAD, or features that you can use. The reason why is when I select my geometry, I can just pick up my hole model here, and what it's going to do is what it should do here. Let me see. I'm not let me check this again. We got cross drill. Axis of rotation is the x-axis. I feel like maybe I need to pick an axis here. Let's delete all. Let me see here. I should be able to just window pick this model here and have it throw out the machining features that are not aligned with a cross hole. Okay, it looks like I may be on a different build here, so I do apologize about that. But when you do your drill cycle, select geometry. This is a cross drill cycle. Okay, you can actually select your entire model, and it will filter out the geometry, or that's really what the purpose is here, is to filter out the geometry to only drill the cross holes. And that's why I like this feature so much. Now, for some reason on the build that I have, it's picking up all these different sizes of the diameter, but I think okay, I understand. Hold on a second. It's my bad. It's not the build, it's my bad. Let me do it again. Let's do drill hole. select geometry. This is a cross drill cycle, and the axis of rotation is along the x-axis. I was selecting the wrong axis here. Okay, so the axis of rotation is going to be down the center. I'm going to window pick my geometry here. I'm going to choose OK, and it's going to throw away all the other geometry that, all the other holes that do not cross the axis of rotation. Again, that's what makes this so powerful, is I'm able to come in here. I'm just going to compute it. I'm able to come in here and I'm able to program just the holes that are intersecting with the axis of rotation. All right, now there are some group retracts, like when we're dealing with our group retract, we can say the axis of rotation. We can say, you know, this is where the group retracts can come in pretty helpful as well. You know, this is how it's going to program these different hole locations. So you can see it's finding the ones that intersect with the axis of rotation and programming those. So cross drilling is a super useful feature here. Let me find a different file here real quick. Drilling. Let's see here. Okay, so this is another example where we have a bunch of holes that we're cross drilling. You know, I had a misunderstanding about this. I do make mistakes myself. I am human. When I was explaining cross drilling, or how I thought this actually meant, was the tool was crossing the axis of rotation, or in other words, you were getting a Y move. Okay, that is actually not what is happening. This is for holes that intersect with the axis of rotation. So let me reselect here. We can pick up our model. We'll say OK, compute, and it's going to find all our cross holes for us. So that is a super useful feature, especially for you 4-axis users. If you haven't tried it, I would definitely recommend getting there and working with the cross drill feature. Okay, so for your 4th axis, you're a mill turn guys, you're really going to like the cross drill feature. It's going to pick up holes that intersect with the axis of rotation, and it's going to throw away other holes that do not intersect with the axis of rotation. Okay, and the last one that we have here is this multi-axis drilling. Give it just a second to open up this file. Okay. Multi-axis drilling, this you're going to use for your 4 or your 5-axis machines. This is where you're able to drill holes that are in different orientations, okay? And you can use the selection method here. Let's reselect multi-axis drilling, and then you'll see these arrows. These arrows are indicating the direction that the hole would be drilled in, and we're able to drill these holes that are on different angles. So multi-axis drilling is very useful. Another question for you guys, your 4-axis guys, are you using a dovetail fixture in your 4-axis? If you are, that could be a really useful setup option for you to get your standout and your dovetail fixture and be able to hold the part and be able to turn the part in different orientations. So I just kind of wanted to bring that up real quick. If you're using dovetail fixtures, go ahead and let me know. I don't know, Vic, are you using dovetail fixtures for your 4th axis? If you are, awesome. If you're not, no big deal. Something you may consider. Okay, no. All right. So again, with the multi-axis drilling, this is where you're in a 4 or 5-axis machine. We'll go ahead and delete this feature here. Okay. So we have some holes that we need to drill along this model here. We're going to come in and choose drill hole. We're going to select geometry. We're going to change this to multi-axis drill. All right, from here we'll pick our cylindrical faces, and then you'll see this arrow here. The arrow is determining what direction we're drilling in. There is a reverse option, so you can select this and reverse the direction if it's going the wrong way. This way you can get them going in the proper direction. So you can go through and select these holes. By selecting these holes, BobCAD will calculate the angles in order to drill the holes in the proper order. So we'll do all of these here, and then we'll grab the other side. So again, this is 5-axis drilling. You could use this with your trunnion table, your Haas UMC 750. really any your Hercos, whatever machine that you may be running where you have 5-axis. Let's see, reverse chamfer, bottom of holes, dovetail, lollipop. Yeah, we can do that, Thomas. If you're a mill premium user in 3-axis, you can definitely do cross holes and back chamfering with lollipops or a dovetail. So you use the surface-based toolpaths for that. Usually like a morph type strategy is what I use. I guess it's possible to use some of the other strategies as well, maybe a project curves, but usually I'm using a morph type strategy for cross holes and back chamfers in that example. Okay, so we got this set up here. We're going to go through. It's going to pick up the different hole depths. We'll throw a drill cycle on the other side here. We're going to compute it, and you'll see that it will pick up all our depths for us, and it's going to align this tool to each hole location for us, which is really pretty cool. How this works. So this is multi-axis drilling. If you're a 5-axis user or a 4-axis user, you can use this for BobCAD to automatically pick up the rotation. So those are our 5 types of drilling. We have our standard drilling on points, arcs, arc segments or surfaces. We have our 3-axis drilling using our hole groups. We have our cross drilling, being able to work with parts on your 4th axis or your mill turn. And then we have our multi-axis drilling using your 4-axis and your 5-axis machine. All right, so is there any other questions about that? If there is, we'll go ahead and answer it now. Otherwise, I'm going to wrap up the webinar, and then I'm going to I'll wrap up the webinar, and then I'll open it Q&A to answer any off-topic questions that you guys may have. Okay. £7,000 part flip. Why? Thanks. Yeah, I completely understand. Very good. All right, guys. When it comes to BobCAD, there's one thing that we feel is super important, providing you guys great value, but most importantly, providing fewer steps, better cuts, and more profit. I look forward to seeing you guys in the next webinar. Thank you so much for spending some time with me here today.